Okay, so today we are going to cover lesson 11.2, and these are going to be decimal forms of rational numbers. Now, a rational number is just any number that can be written as a fraction. So what we're going to be doing here is you're going to be given fractions, and we're going to be converting them to decimals. And the way that we're going to do that is we're going to be dividing the numerator by the denominator. Now, the first few examples, we're going to be encountering what's called a terminating decimal. And what that means is when I divide, I'm going to get a remainder of 0. So it'll go in evenly. Now, I am going to have to add zeros in order to get it to terminate. So in my first example here, I have 3/8. To convert this to a decimal, I'm going to take the numerator, the 3. I'm going to put it in the division box, and I'm going to put a decimal point and then a 0 behind it. And I do have a delay here. Let's see if it's going to catch up. All right, so now I'll begin my division. Now, if it would go into 30 evenly, then I would just multiply and subtract. However, you can see that 8's not going to go into 30 evenly, but it'll go in there 3 times. So I'll do 8 times 3 and get 24. Subtract, bring down the 6. I need to keep trying to see, and I'm going to keep dividing and keep adding zeros until either I get a remainder of 0 or I see a pattern developing. Now I'm going to bring my decimal point straight up. I'm going to add another 0. Try to divide 8 into 60. Again, it's not going in evenly. 8 times 7 is 56. I'm going to subtract. I'm still going to bring another 0 down, but now finally, 8 times 5 is 40. I get my remainder of 0. So this is an example of a terminating decimal because when I divide, I actually get a remainder of 0. So the decimal equivalent for 3/8 is 0.375. Let's try another example. So again, it wants us to try to do each one of these and write it as a decimal. So I don't know what happened here on this didn't completely erase, but we'll go ahead and see what's going on here. Now, the first one, when I go ahead and I put in, now these are going to be examples of repeating decimals. So again, if you do not get a remainder of 0, what we're going to look for is if there is a pattern and the numbers on top of my division box repeat. And then as soon as I can see a repeating pattern, I can stop my division. So I'm going to put 5 in the division box, add a 0 behind it. The denominator goes outside the box. Bring the decimal point straight up. 6 will go into, it won't go into 5, but it'll go into 50 8 times. 8 times 6, 48. Subtract. Put another 0 there because I did not get a remainder of 0. 6 will go into 20 3 times. Multiply. Subtract. Notice I keep getting the same number. So now I can start to see that I'm going to get a repeating number. Now, when you write your decimal as a repeating decimal, what we're going to use is bar notation. So you could say that this is 0.8, and then only the digit that repeats gets the bar on top. Okay? You might also see it written with 3 dots. So 0.833, and then you could put 3 dots after it. Generally, the bar notation is what you're going to see for repeating decimals. Let's try this 7/11. Again, put the numerator in the division box, the denominator outside. 11 won't go into 7, but 11 will go into 70 6 times. 6 times 11 is 66. Subtract, bring down the 4, bring down another 0, and then it'll go in 3 times. Subtract, bring down another 0, and notice now I'm starting to get a pattern of 6363. So this time my answer, you can either write it as 6363 with ... or put the bar over both numbers. So this is a repeating decimal. I could not get a remainder of 0. Now, the next example is a mixed number. What they're having you do is make it improper and then divide. Now, another way that you can go about doing this, so you do have the example in the book where they made it improper, 7 times 3 plus 2, and that gave you 23 over 7, and then they divided it. Now, what you could also do is realize that the whole number in your mixed number here is going to be in front of the decimal point. And then if you wanted to, you could just divide the 2 by 7 and then get what remains behind the decimal point. Now this one, if you look in your book, you've got to take it pretty far before you can actually get the pattern that repeats. So 7 doesn't go into the 2, but it'll go into 20 2 times. 14, subtract, and we get it'll go in here 6, bring down the 0, and then it'll go 8 times, subtract, bring down, we don't have a pattern yet, it'll go in 5 times, no pattern yet, got to keep going. Now, if your instructions tell you to round to a specific decimal place, if it said round to the tenths place or the hundredths place, we could stop. But if it says find the repeating decimal, then we have to keep going until we find the pattern. So 7 will go into 50 7 times. Still no pattern. It'll go in here once. Still no pattern. And then it'll go in here 4 times. Bring down another 0. And then it'll go in here twice. And now we're finally going to start to see the pattern. So look how many numbers we had to go before we actually saw it start repeating. So this is now going to just keep going. 8, 5, 7, 1, 4, 2, and keep going. So if it says to find the repeating pattern, you're going to keep dividing until it gets there. Now, if it again says to round, then you would stop one number past the rounding position. All right, on the next page, this is talking about non-terminating decimals. So these would be like examples of irrational numbers. So these are non-terminating or repeating. So notice the number that repeats in the 5 6 was the 3. The numbers that repeated in the 7 11s was the 63. And then this is the one that we had to take it really far. So here they're showing you the bar notation. You only put the bar over the numbers that repeat. Now what we're going to do is we're going to go the other way. I'm going to give you the decimal, and you're going to write it as a fraction in simplest form. So again, each one of the numbers after it is like a power of 10. So the first number after a decimal point would be the tenths place. So like 0.5, you would write that as 5/10, and then you would simplify. So the example here, 3/8. This 8 is in the hundredths place. So you're going to write it as 38 over 100. And then you need to reduce. You can divide them both by 2, and it becomes 19 over 50. There are 3 numbers behind this, so this is in the thousands place. So 425 over 1,000. And again, you need to simplify. I can divide this by 25, and let's see, 1,000 divided by 25, and it goes in here 4 and 0. And then when I divide 425 by 25, I get 17. Now, if you didn't realize 25 went in there, you could have started by dividing it by 5s, but just know you need to write it in simplest form. Now, the next part's a little tricky. Okay, so whenever there is no bar notation, whenever it's a terminating decimal, the denominator is either going to be a 10, 100, 1,000, depending on the number of numbers behind the decimal point. A clue here is, notice there are 2 numbers behind the decimal point. So that would mean there's 2 zeros in the fraction, in the denominator. This has 3 numbers, so you put 3 numbers, 3 zeros in the bottom. Now, for the repeating decimals, it's going to have 9s in the bottom, or 99, or 999. And the way that we're going to do this, there's a whole formula. So this is the part that you've probably not seen before. It is taught in an 8th grade curriculum. However, I know some of you might have skipped some parts of the 8th grade curriculum. So watch the process for converting a repeating decimal into a fraction. So here is the process. I'm going to take my decimal, my repeating decimal, and I'm going to have n equals it. So n equals, and I'm going to leave a little gap here. Next, I am going to, however many numbers there are with the that repeat, and notice here there's 2 numbers that repeat, I am going to multiply that by 100. Now, if only 1 number repeated, then I'd multiply it by 10. So basically what you're doing is the number that repeats is going to be the exponent. So I have 2 repeating, so it'd be like 10 to the repeating decimal part. So there's 2 numbers that repeat, so I'm gonna multiply the number by 100. So up above here, I'm gonna write 100n, I'm gonna multiply both sides by 100. I'm also gonna do the top, and it's gonna become 100 times, let me move this up a little. I'm gonna do it to the side. So 100n equals 100 times 0.542. So I'm taking my original equation, this one, and I'm going to multiply both sides of it by a power of 10 of the number of repeating decimals. So there's 2 repeating decimals. Okay, so here 2 numbers repeat, so that's why it's 10 to the 2nd power, and it's 100. I multiply both sides by 100. So now I'm going to write the result on top here, 100n equals, and when I multiply a decimal by a power of 10, really all I have to do is move the decimal point the number of zeros. So this is actually going to become 54. So if I take 0.542 and I move it 2 times, 1, 2, I get 54.2. But remember, this bar meant the 4 2's kept repeating. So I need to have enough numbers lined up on top of each other. 5, 4, 2, and then they cancel out. Okay, so again, the repeating part is the 4 2's. I need to get everything lined up here. So when and I just messed this up. So look at this. So this is wrong. Let me fix this. Because remember the number was 542. So it should be 5, 4, 2, 4, 2. So I could keep writing everything that keeps repeating. Now that I have these on top of each other, I'm going to subtract the two equations. Notice the 4 2's, the 2 here cancels, that becomes a 0. And then here I'm gonna borrow, and this becomes 53.7. And then 100 minus 1 gives me 99n. I need to divide both sides by 99. And now I have n is equal to 53.7 over 99. I cannot leave a decimal in my fraction, so I'm going to multiply the top and the bottom by 10, or essentially move this decimal point once and move this once, because timesing it by 10 will move the decimal point. I now have 537 over 990. That's my fraction, but I need to see if I can simplify. I can actually divide them both by 3 and reduce it to 179 over 330. And that would be your fraction. So the fraction equivalent for 0.5 and then 4,2 repeating, the fraction equivalent is 179 over 330. You will have to do this on the test on Thursday. You will have to convert something where all the digits do not repeat. I'm going to do another example of this. The next one. Now, notice it's a negative decimal. I'm just going to make sure that when I write my final answer, my fraction is also negative. So again, I'm going to set n equal to the 0.375. Notice I left a little space there. Okay, notice this time 3 numbers are repeating. So on top, I'm going to put 1,000, 3 zeros there. And then I'm going to go over here and I'm going to write 0.375, 375, because I need to move my decimal point 3 times. 1, 2, 3. So over here, I'm going to write 375.375. Now I can subtract my equations. I'm going to get 999n. Notice when I subtract this, the 5 gets a 0, a 0, a 0. So it's just equaling 375.0. So this time I didn't have a decimal in my fraction. Divide by 999. And I get n is equal to 375 over 999. Again, I need to try to reduce, and I can divide them both by 3. 375 divided by 3 is 125. 999 divided by 3 is 333. And that would be the fraction equivalent. So really shortcut for this, when all of the digits repeat, your denominator will be a 99 or 999. So for example, if you have 0.2 repeating, instead of going through the whole process, know that this will automatically become 2/9. If you have 0.22, both of the 2's repeat, this would be 22 over 99. And then you'd have to simplify. And again, this would also simplify to 2/9. It's when only part of the decimal repeats that you need to go through this whole process. You can use it every single time, even when all the numbers repeat. So all terminating and all repeating decimals that have a pattern to it are rational. The irrational numbers are numbers that when you divide them, there's no pattern. It just goes on randomly. All right, the next part is talking about rounding decimals. So a lot of times when you take a standardized test or even a test, they might say, round your answer to the tenths place. So just remember that you're gonna look to the right of the place that you're gonna round. If it's 5 or bigger, you round up. If it's less than 5, you just keep the number the same. So they're talking about rounding in that part of it. And they'll tell you the specific place to round to. So again, all you're going to be doing here is a lot of division problems. So here it says, express each rational number as a terminating or a repeating decimal. When you're writing your answers for the repeating, use the bar notation. So for example, on these oral exercises here, number 11, if I were to express 1/2 as a decimal, I take the 1, I put it in the division box. 2 won't go into 1, but it'll go into 10 5 times. Notice you get a remainder of 0. So the terminating decimal for 1/2 is 0.5. So for the repeating decimals, you would divide them and use the bar notation. So for example, 8/13, this one would repeat. Put the 8 in the box, and then you would divide it. So 13 won't go into 8, but it will go into 80. So it'll go 6 times. This one's going to take a while to get the pattern, just like the other one. So you would just keep dividing this until you can see a pattern. This one actually repeats. This one might take too long. Let me see. Let me see if there's an easier one. Let's just say 1/3. Let's just do that one. So if I put 1 in the division box and divide it, 3 won't go into 1, but it'll go into 10 3 times. And notice the pattern is already starting. So this would be 0.3 repeating. You notice the 3 just repeats, so you could just write 1 3 if you wanted to write 2 3s with the bar over top, either way. So when you're decimal, after you're doing the division, once you start to see the pattern, put the bar over the digits that repeat. So your homework for this lesson is 1 through 28 all. So you're going to be converting from fractions to decimals and then decimals back to fractions. Again, for the repeating ones, when you get down to the bottom of the homework, do that formula that I showed you. Again, it walks you through step by step in your book, or you could watch the video again. So that is all for 11-2. Tomorrow we're going to look at finding square roots. Tomorrow's square roots will be perfect squares. Then the next week we'll do the non-perfect squares. And finding square roots are going to be very important to you next year in geometry, because if you are coming here for geometry, you will not be able to use a calculator to break down square roots. You will have to do them by hand. So next week's lesson will be very important that you understand how to do it. So that is it for 11-2.